Okay, so here is my 15 or more minute video for the Chapter 6 and 7 exam. So I've got it all, I think, 100% correct. Again, that'll be up to you when you end up grading it. So, well, let's just dive right into it. So, question 1, we've got the shell and washer method. I guess that feeds into question 2 as well. So what we have here is we start with the washer method, which, as I showed up here, would be, since we're rotating around the x-axis, the washer method would be anything by terms of dx, because that goes perpendicular to the line that we're rotating around. So over there we set up the equation for that, and actually before we can even solve for anything, we have to find what our bounds are, so I just set everything to equal each other, so the 3x squared equals 5x. I don't know, it was nice and easy, so we got down to 0 and 5/3, I believe it was. Let me look. Yeah, 5/3. Because you can separate the x squared out there and set both of those individually to 0. And then whatever it equals is your bounds. So it'd then be the 2 pi times this, or 2 pi times this, because that would be the rotation. And then basically you just integrate, and that comes over here, and that gets you an answer of 125 pi over 27. Now, for the shell method, that is anything that goes parallel to the axis of rotation, so that's going to be all of your dy's. So basically what I just did is I set both of them equal to y, and then for this one over here, because it's a square and you can take a square root, it would be positive or negative, but in our case, because it's only in that first quadrant, we're going to want the positive square root. So then you can set it, same issue over here. The only difference is you're going to want the y values for these interceptions over here. So basically what I just did is I multiplied, or I set the point 5/3 in the equation here. And what you're going to want to do is just take that 5 over, so it's going to be 25 over 3. I believe that's what I got. Yeah, 25 over 3. Oh, I need to correct that, because I accidentally messed up on the first one and tried saying it was 10 over 3, which it is not. Because I decided to do addition instead of multiplication, because I felt like it. And I know that's wrong, so I fixed it. Okay, so back to what we were doing. You just integrated again, fairly simple. And then it also came out with 125 over 27. I just forgot to write the 2 in front of the 27. So 125 over 27, just like the other one. And yes, those should both be equal, or maybe not. I don't think they actually have to be equal because you're rotating it around different axes. It just happened to be equal this time. All right, now down here, it required you to do this equation over here around the line y equals 1. So what I did is I did the shell method, as stated right there. And I found the bounds over here, 0 and 1, and because it's only in the first quadrant, that would make it that 0 and 1, because that's where it hits the y-axis. You move further over here, and you're going to have your integration. You set that up nice and good there. And then you integrate it, and I got 2 pi over 5 as the final answer. Now, moving on to question 3? Yeah, 3. It's cut off by the staple. Okay, so question 3, we're moving into length of the curve. Now, that one is the, so you have the bounds, and then it's root 1 plus dy dx squared. So what you got to do is you just got to find dy dx. In this case, it's x squared over 3 minus 1 over 2x squared. And then you put that into there. Now, fun part is you can use the do properties of squares, so you could pull those two apart and then do FOIL. Foiling that out would get you this right here, and then because there's the 1 right there, you can put it into that -1/3, and it would become +2/3, and then you can take the square back out, which would just get you the this here, which would just be x to the 4th over 9 plus 1 over, or no, that's not it. X squared over 3 plus 1 over 2x squared. And then when you integrate that, you come up here, it would come out to this, and then my final answer, after I got all of that, was 493 over 45, I believe. I might have accidentally left out, no, because there's no 2 pi in that because we aren't finding an area. So yeah, that would be your final answer, 493 over 45. You move into question 4. That one was pretty nice because everything factored out to a very, very nice thing at the very end. Something I could very easily plug stuff into. So you go into this looking at the fundamental theorem of calculus. So you have the this times the initial and then the final over the bottom. It's the fundamental theorem, and it's going to end up coming out to pi over, or bounds are pi over 6 and negative pi over 3 of root, the root of the, yeah, I might have wrote that wrong, but my brain knew what it was doing, maybe. But what you're going to do, because you're trying to find the length of the curve there, is you're going to root all of that, the final answer that you got from fundamental theorem of calculus, and then you're going to add 1 to it, just like you did up in here. And then the way that works, because you're squaring a square root, that all cancels. So what you're going to have is secant y to the 4th power minus 1 plus 1, which would just end up coming square root of secant to the 4th y, and then if you square root that, you get secant squared, secant squared y, which the integral of that is just tangent, and then you plug in your bounds, and voila, here are your bounds, or here's your final answer, root 3 over 3 plus root 3. Or minus 3. Yeah, it'd be minus 3, not plus 3. Wait, no, it would be plus 3 because it's minus a negative, blah, blah, blah. We're getting there. And then for question 5, we have, we're starting to get into surface area, so that 2 pi's coming in again. So, integrals, again, we have in this case, it'd be 2 pi y times the root 1 plus dy dx, or any sort of iteration of that, depending on the variable you're integrating by, or taking derivatives of, whatnot. So in this case, we're doing it in terms of x, so you're going to put the original function in right there, and then you're going to have the derivative of said function squared inside the square root plus 1 here. So the square cancels out the square root in there, and then 1 squared is just 1. So it ends up just becoming 1 over x. And then you can not knock your face out. Basically what happens is that 1 over 1, you can just, again, do math. It's fancy algebra, but it ends up canceling, or taking that x, or that first root x, and canceling out the bottom one over here, which would just get you the integral of x plus 1, which is really easy, and then you just do the 4 pi times all of that, which would get my final answer of 10 pi. Moving on. Here we are with with question 6. Question 6 was interesting for me at first because I had to remember what we did for that 1 plus, I remembered we had to find the common denominator, and for that, it would just be 9 over 9 for this case. So you set it up the same way you would the last one. You have the y over 3, or y third over 9, then the derivative, which the derivative is that over there. Plug it in, and then you can take out a bunch of stuff, a bunch of the constants, and then there's that 9 over 9 there. You get y plus 9 over 9, which would just get you the, or get you this. What did I do there? Why did I write that? Oh, yeah, because I did the square root. Yeah, so you can square root 9, and it would just equal 3, and then you can pull that 3 out front over here, multiply it by that, which would get you 2 pi over 27. And then now you have y cubed times root 9 plus y, root quantity 9 plus y. Gotta specify there. Anyway, so once we get to that, we can do u sub. U would be that inside area of there. Oh, the quantity 9 plus y to the fourth. I know what I'm talking about. I just can't verbalize it, apparently. Then you do du, dx, dx, or yeah. You take the derivative, and then because that derivative is equal to 4y to the third, you can take that 1/4 out to the front, and then multiply it times that, which gets you the final constant, which would be 2 pi over, or coefficient, not constant, of 2 pi over 108. And then that would get you, or in that other y cubed would take out the y cubed in front over here, and then that would take you over to here. Now you'd have to change your bounds because you did u sub, so I got my upper bound to 17, lower bound to 9, and then you integrate, and that right there is my final answer, pi times pi times quantity 17 root 17 minus 27 over 81. The next one is Hooke's law. Kind of disappointed I didn't remember this in class, or at least I wasn't confident enough, because when I got home and looked at it, and I was like, really? I already looked at that, and I was very confident in that, and I could have done it in class, but instead, my nerves, I doubted myself too much. But anyway, Hooke's law, nice and easy. Basically, the 140 pounds would be your work there, or your force, times x, which would be that coefficient, times 0.14 inches, because that's the distance it traveled. Your x, or your coefficient, would be 1,000, and then your work equals 0 to the compression for 60 pounds. In this case, we had to solve for it, and it ended up being 0.06. So 0.06 would be there, and then times the coefficient x dx. And then that would come out to about 1.8 inch-pounds. I think that's the unit that we use for that one. So, moving on to question 8. Budgeting time. How many do I have left? Okay, 13 minutes and a couple questions, quite a few questions left. We're doing good. Find the work required to pitch an 8-ounce softball 150 feet per second. So 8 ounces, half pound, nice and easy. Conversion factors, yay. And then to find the mass, you had to find that related to gravity, which should, in our case, because it's the integral, would be 32 feet per second squared, which would end up being 1 over 64, and then you can use the physics thing. Yes, brain don't work. 1/2 times 1 over 64 times 150 squared, which would get me my final answer of 75 over 64 foot-pounds. Okay, this is where I had a little bit more fun, because I ended up having to completely get rid of almost all of the work I did over here, and all my other work is right here. And I still have no idea if this is right. I think it's right, but that's up to grading for you. So anyway, we had the it's half full, so I labeled that over here so that it was only 10 out of the 20. And because it's only the 10 out of 20, your bounds are 0 to 10. And then you have the pi times 6y squared, so you only square the 6y, not the pi. And then it's 20 minus, not plus y. Let me fix that real quick. 20 minus y. and then you would take out all of your constants, so it'd be, or your not your constants, your coefficients. Math terms, gotta get those right. So 50.6 times 36 pi times the integration from 0 to 10 of 20 minus y. Integration's pretty easy for that, and then that gave me 858,408.78 foot-pounds of work for question 6. No, that's not 6, that's 9. Moving forward. So the conic one, actually I found that one to be a little bit easier. I don't know why. Probably because I've done so many conic ones for practice. But pretty much the same values other than what you're doing the math with right here. So basically the same, you just integrate through, and I got a final answer of 41,397.028 foot-pounds. 7-1, the inverse, or the derivatives of an inverse. So the property for that, I actually just need to extend that line straight up and down. It's 1 over the derivative at that f of 2. So I didn't even bother taking the inverse of that. I just put the derivative of the function straight into 1 over, and then plugged 2 into that equation, and it came out to be 1 over negative 8. On to the last page. This one, boy did I like this one. I liked this page. I started with this one, and boy am I glad I did. So, logarithms, derivatives of logarithms. That one was nice and fun, and I basically just combined the two at the bottom to just make sure. And we got to make sure it's an absolute value, because those negatives could really kind of throw you off if you decide to put those in, because you can't take a log of a negative. Or it can, natural logs can only be positive, something to that effect. But you have to make sure that when you're taking the derivative, or yeah, the integral of that, it has to be absolute value. This one here ends up being logarithmic because you can convert that from tangent into sine over cosine of 3x, and then you just do a bunch of like chain rule and stuff, or like reverse chain rule, and some u sub to get it down to this final answer, which would then get you negative 1 over 3 ln of the absolute value of cosine 3x plus c. And you add that plus c because it's the obligatory or is that a constant? I think it's a constant now, but because you don't have bounds. So this one right here, I'm not 100% sure I did right. But basically what I did was take the log, or natural log of both sides. And then after you get done with that, once you derive that, you're going to have dy dx times 1 over y, with the derivatives chain rule, a bunch of chain rule in there. So I did the derivative of the log, or natural log, then the derivative of the, root, and then you do the derivative of the inside. And then when you plug all that in together, because you transfer that 1 over y to just be y, you can plug in the original function, and then this, and then these two roots right here I think would cancel out just to give you that instead of that, or square root of that. And that would be my final answer right there. Now for this one, proving that this is right, I just worked out everything nice and simple. A times 1 over ax, a over ax, a cancels 1 over x, and then just this, because I know it, is 1 over x, and those are equal, so therefore that is true. And then, favorite part of this class, derivatives. I enjoyed them. They worked very well. And that is my video for this. I hope it's all completely correct, because as far as I understood from the email, if it's not, it doesn't count. So great. Have a wonderful summer, and thank you for giving us this opportunity to not fail an exam.